Assalamu alaikum. Welcome back to my video series on data science. In the previous lectures, we talked about machine learning models and their training. Model training is just the beginning. To truly understand how well your model is performing, evaluation metrics are the key. In today's video, we will explore evaluation metrics for both classification and regression tasks. In the coming lecture, we will talk about the evaluation metrics for clustering. Some common evaluation metrics for classification includes accuracy, precision, recall, F1 score, specificity, ROC-AUC curves, and Matthew correlation coefficient. The provided data represents the actual and predicted values for a binary classification model for cancer detection. In this problem, our goal is to develop a model that precisely detects all cancer patients without any errors. Actual are the true ground truth label for each data point. Predicted are the predicted label assigned by the model. Comparing the actual and predicted values, we can determine true positives, true negatives, false positives, and false negatives. Class indicated by 1 represents cancer and it is positive class, while class indicated with 0 represents healthy, hence negative class. If we look at the first instance, actual and predicted both are negative, which means the patient did not have cancer and the model also predicted no cancer. So it is called true negative. Next instance also represents the same. In the third instance, actual class was positive, but the model incorrectly predicted it as negative. So we call it false negative. Next three instances are again true negatives. In the seventh instance, the actual class was negative, but the model incorrectly predicted it as positive. So we call it false positive. If we look at the last instance, the actual class was positive and the model also predicted it as positive. So we call it true positive. So the true positives and true negatives are the correct predictions and false positives and false negatives are the errors. We have one true positive, 6 true negatives, one false positive, and 2 false negatives. The foundation of evaluation matrix in classification lies in confusion matrix. It summarizes the results of predictions into 4 categories: true positives, true negatives, false positives, and false negatives. Now let's come to the evaluation matrix. Accuracy is the simplest metric. It measures the percentage of correct predictions. Mathematically, it is the sum of the true positives and true negatives divided by the total prediction. Total predictions are 10, out of which correct predictions are 7. So we have an accuracy of 70%. Accuracy can be misleading metric, especially when dealing with imbalanced datasets. In such cases where one class significantly outweighs the other, a model can achieve higher accuracy by simply predicting the majority class. For instance, in a medical diagnostic scenario where cancer is a rare occurrence, a model that always predicts no cancer would have a high accuracy but would be completely ineffective in identifying actual cancer cases. To evaluate models on imbalanced dataset, we should consider more metrics like precision and recall. Precision tells us how many of the predicted positives are actually correct. It's crucial in scenarios like spam detection, where false positives are costly. Mathematically, it is written as true positives divided by true positives plus false positive. So our precision is 0.5, which means 50% chance based. Recall focuses on true positives that are correctly identified out of all actual positives. It is important in medical diagnosis where missing a true case can be crucial. It can be calculated by dividing true positives with the sum of true positives and false negatives. In our case, it is 0.3, which means the cancer detection rate is only 33%, although the accuracy was 70%. F1 score is the harmonic mean of precision and recall, balancing the two. It is useful when dealing with imbalanced dataset. If the precision and recall both are high, the F1 score would be high. And if the precision, recall or both are low, the F1 score will be low. True negative rate or specificity measures the portion of actual negatives correctly identified by the model. It focuses on how well the model avoids false positives. So we can see that the model is doing good when detecting the negative classes. The Matthews correlation coefficient is a comprehensive metric for binary classification that accounts for all four outcomes: true positives, true negatives, false positives, and false negatives. It gives a balanced measure even if the classes are imbalanced. MCC ranges from -1 to +1. 1 means perfect prediction, 0 means random guessing, and -1 means completely wrong predictions. The ROC-AUC measures the ability of a classifier to distinguish between classes, plotting the true positive rate against the false positive rate. An ideal classifier must have AUC close to 1. In our case, the area under the curve is 0.6. Now let's talk about the evaluation metrics used for regression tasks. Some common evaluation metrics include mean absolute error, mean squared error, root mean squared error, and R squared. Mean absolute error calculates the average absolute difference between the predicted and the actual values. It's easy to interpret and gives equal weights to all errors. Mean squared error squares the errors before averaging, penalizing large error more heavily. It's sensitive to outliers. Root mean squared error is the square root of mean squared error, bringing the scale back to the original units of the target variable. R squared explains the portion of variance in target variable that is predictable from the independent variables. Values closer to 1 indicate better performance. In our case, almost 60% of the variance in the dependent variable is explained by the independent variable. So in today's session, we discussed different evaluation metrics for classification and regression tasks. In the coming lecture, we will talk about evaluation metrics used for clustering tasks. If you found this video helpful, don't forget to like, share, and subscribe for more videos on data science and AI. See you next time.